Jupiter, which is the next planet in our line of the solar system, is that a lot of people seem to think that Mars is like the ideal place for humanity to go right now. It's really not. So the size of Mars is just over half the size of Earth. So anyone who's going to be standing on Mars and running around is going to be facing like gravity that's like half the size. So that's probably not great for a lot of reasons. I'll let all the medical people in the comments debate that. But yeah, Mars is really not a great place to go. However, it definitely beats the sulfuric acid clouds and the lead melting weather of Venus. So yeah, that's just an interesting thing about Mars, because before I started like doing space engineer stuff, I really thought that Mars had like the same gravity as Earth and was like the same size. Yeah, it's not. It's so much smaller. Little Mars, the little red planet that could. All right, we're done with Mars. Time to move on to the good stuff. And I'm talking about Jupiter. However, oh my, oh man. So this is where things get a little bit interesting, because up until now, is that ice? Huh. It's just a randomly generated asteroid for Deimos, by the way. But up until now, when we're traveling to each of the planets, we can no longer do that, because do you see the distance there? What is that? 1.83 LS. Does anyone have any idea what LS stands for? I mean, I could tell you, but you care to venture a guess? LS is light seconds. I didn't even know the game could measure in light seconds. So it turns out in space engineers, and this is one thing I didn't know before doing this, once you get past a certain distance between two objects, the game starts counting in light seconds, which is crazy. Light seconds, my dudes. 1 light second is 299,794 kilometers. So that's pretty much just how far light travels in 1 second. So you can imagine when I was actually putting the planets in place, this caught me off guard. I was like, what's a LS? Do I really have to measure an LS now? Yeah, pretty much, but it's fine. Basically, that just means we can't fly there anymore. We could, but it would just take us a really long time. In fact, I think going there would take us about 2 more of everything we've done so far. So yeah, we're just gonna teleport. We'll teleport via our entity list showing the planets. All right, and just like that, here we are in Jupiter, our largest planet in the solar system. Jupiter is the first planet we've come across so far that's even close to the normal planet size in Space Engineers. In this model, Jupiter has a radius of about 69 kilometers, compared to the normal Space Engineers planet, which has a radius of about 60 kilometers. So Jupiter is just a tad bit larger than the normal planet in this model. In addition to being our first gigantic planet, it's also a gas giant, meaning it doesn't actually have a rocky core. Well, it might have a rocky core, but it doesn't actually have a rocky surface like Earth does. If it has a rocky core, we don't know it yet, because everything we try to send into Jupiter just gets pulverized. We tried it one time with a satellite. It exploded. We got some data from it, but it was pretty much a suicide mission for poor satellite. I don't remember the name of that. If any of you guys know the name of that satellite that we sent in, post that down in the comments. Jupiter is made up of mostly hydrogen and helium. That's what all that gas is mostly made of. Jupiter has this big superstorm that's right in the middle of it, and it's kind of like the defining feature of Jupiter, other than these cool traces of gas. And interestingly about this is this little storm right here, the low-res storm that we're looking at, because this is Space Engineers, is 2 times the size of Earth's whole planet. So you could fit 2 Earths in there. Another interesting thing that I didn't know about Jupiter before starting this is that Jupiter has auroras at its poles, and they're like intense auroras. Like there's video of them, and in fact I'll try and put that on the screen now if I remember. There's video of those auroras, and they look so cool. It looks like something out of a sci-fi movie, if I'm being honest. But yeah, Jupiter has auroras. Confirmed. Jupiter is truly a cool planet. It's got like 79, I think, moons compared to R1 and compared to Mars's 2. Well, let's take a look at some of those moons. Starting out, we'll start with Europa, which is probably the coolest moon well, one of the coolest. There's some really cool moons in here, not gonna lie. So Europa has an icy surface. It's all ice pretty much. And then underneath it, it's got liquid water, which is pretty insane. In fact, before starting this, I didn't think that I didn't think liquid water existed anywhere in the solar system. But here, this is just the first of many moons we're going to take a look at that have liquid water. So Europa, yeah, ice with liquid water underneath it. So I call it Hoth in my Let's Play series. It's not far off. pretty much Hoth. But since there is liquid water underneath, Europa just so happens to be one of the few places in the solar system where life is possible. Like, there could already be life there, and we just don't know it. Like living under the ice, on in the normal water. So there could be life on Europa. It's certainly a possibility, or there could not be. Who knows? It's just really cool to think about that just this moon has the capability for life, and that's why Europa is super awesome. Let's move to Io. Is that pronounced Io? How do you pronounce that? Io? Hi. Oh, let's go. I was flying to the moon. Burn, burn. Next to Jupiter. Now burn, burn. It was really, really far. Io, man. Okay, Io, Yo, or whatever it's called. I used a Mars model for this because I didn't have an Io planet model, but the actual moon is like super yellow. I can only describe it to you guys. You can look at pictures. Maybe I'll post pictures as well. But Io is a very hostile place, kind of like Jupiter, or kind of like Venus. It's got volcanoes everywhere. It's very, very deadly. Io is the most volcanically active place in the solar system. Just this one moon right here. It's got volcanoes all over it, and it's always exploding and causing nasty stuff to happen. And I believe the volcanoes, if I remember correctly, don't quote me on this, I believe it's because of tidal forces with Jupiter, which we'll explain later when we talk about another moon as well. But tidal forces cause volcanoes. Pretty sure. Don't quote me on that. But if you ever need to know one thing about Io, it's that it has volcanoes all over the place, and it's yellow. It's a yellow moon. Let's move on to our next one. Over in this corner, we're skipping Ganymede. We've got Callisto. We'll come back to Ganymede, don't worry. Callisto is a large moon, quite large. It's got lots of craters everywhere. That's one of the defining features of Callisto. In fact, it's the most cratered body in the entire solar system. Just this one moon right here, orbiting Jupiter. And another thing about Callisto is that there's a possibility for liquid water underneath the icy surface of Callisto. Well, not all of Callisto is ice, but you know, where there is ice, there's possibility for some of that H2O, according to NASA. And finally, let's move on to Ganymede. Where's Ganymede? Ganymede is the largest moon in the solar system. It's mucho bigo. Ganymede is actually larger than Mercury, so this moon here is larger than a planet, which is kind of insane. Ganymede has lots of ice on the surface of it, although I'm not sure you can tell by this, but like the real Ganymede has lots of ice on the surface. And Ganymede, surprisingly, is the only moon with a magnetic field. All the other moons can't generate their own magnetic field, but Ganymede can, because Ganymede's a boss. It's freaking awesome. And again, with a lot of these, just like with a lot of these moons, there's a possible underground ocean underneath Ganymede, according to NASA. And Ganymede has auroras, just like Jupiter and Earth. Beautiful little displays of light. So that's Ganymede. We've got Callisto. We've got Io, and we've got Europa, the moons of Jupiter. They're really cool. It's really cool once you get to Jupiter and Saturn because their moons are so awesome. Like all of these, I think except for Io, have the possibility for like liquid water underneath the planet, underneath the moon, which is just crazy to me. Like they can all support life possibly. Callisto over there, Ganymede, and Europa. But anyways, those are the moons of Jupiter. The cool moons, might I add, of Jupiter. Let's move on to the, I would say arguably even cooler moons of Saturn. One thing I do want to highlight as well is how far these things are, by the way, how far the moons are from Jupiter. And I also ask that you remember that this is 1,000 times smaller of a distance than you would actually see. But let's zoom out a little bit. Do you see the planets currently? I mean, you see the planet obviously just right there, but do you see the moons? I'll tell you what, I can see 3 of the moons. I don't know where the 4th one is. You'll probably see them as I'm moving right here. But as I zoom out to get a better view of everything, you might lose them. No, I can still see them. But from this perspective, you really kind of get an idea of how far everything is from each other. But it's really cool because even at this distance, you sometimes see the shadows of the moons on the planet. Which, like, there's some photos of that happening, which is really awesome. All right, but anyways, that was Jupiter. Let's move on to Saturn, which is, well, 2.16 light seconds. No big deal, as long as we can teleport. Now you guys were seeing why I was telling that Elon Musk dude that he's never going to reach Pluto, especially at the speed he's going. Saturn. All right. Welcome to Saturn. Saturn looks a bit weird, but it's only because Space Engineers doesn't really support the rings, as well as it possibly could. But Saturn has rings. That's probably its most defining feature, is that it's big and it's got rings. Just kind of like Jupiter, Saturn is pretty much made of hydrogen and helium, and it doesn't have a rocky surface. It might have a rocky core, we don't know, because it's difficult to kind of see in there, but it does have a rocky, or it does not have a rocky surface like Earth does. These rings you see are actually made of rock and ice that were caused by things kind of exploding in its atmosphere. So like if you can picture like moons, asteroids, comets, kind of coming in here and breaking apart. And then what happens is the pieces that break apart start breaking each other apart as well, and keep doing that pretty much as they orbit around here until they form like a fine layer of rock and ice that forms this nice, beautiful ring. Saturn isn't the only planet that has rings. In fact, some moons even have rings, which is like really surprising to me. But yeah, some other planets also have rings like this, though not nearly as defined. Now we have the privilege of knowing quite a bit about Saturn and its moons, because we did have a probe called Cassini actually go and orbit Saturn like 294 times or something. So we got a lot of really good pictures of the moons and the planet itself. In fact, there's even a really good picture of Cassini, the probe that went there, taking a picture of Earth. Where's the sun? Where's the sun? Oh, the sun's over there. Okay, so Earth's over there. So yeah, the probe was like over here, and it took a picture that way and captured Earth. You can actually see the light of Earth. And that's like, it's a really humbling picture to look at, and I'll put it on the screen as well, because it shows how small we are, how much of like a little dot Earth is in the black expanse of space. It's insane. It's probably one of my favorite pictures out there that Cassini took. But Cassini has lots to offer in the way of pictures from its orbits. Saturn has a bunch of moons. Let's take a look at some of them, like Titan, probably the one you guys are the most familiar with, other than Europa from Jupiter. But Titan is a really special planet. Titan actually has a nitrogen atmosphere, which is very similar to what Earth has. Earth also has the nitrogen atmosphere, but it's the only moon with a substantial atmosphere around it. So our moon has an atmosphere, and a lot of moons have atmospheres, but not like substantial ones like Titan does. In fact, Titan has such an atmosphere that it's said that you could take off your spacesuit and walk around on Titan, provided that you had like an oxygen mask to breathe and a heavy coat. Basically something to keep the cold out. But Titan is really cool in that regard. Titan is also the only place in the solar system other than Earth where you're going to find flowing rivers of liquid. Of course, the liquid's not water, it's hydrocarbons like methane, but it's pretty awesome. Titan has oceans and lakes and rivers of methane. It's also said that Titan might have some water underneath some ice. It's so cold that any water on the surface would already be ice, but there might be some water underneath that ice as well. Of all the places that we could look for life, Titan might be a place that life could be sustained, just because of that atmosphere. It helps keep out the radiation and such, keep the heat in. Well, it's not very hot on Titan. It's still kind of freezing, but still, you get the idea. Titan's a cool place. Aha, here we're coming up on one of my favorite moons here. We have, how do you pronounce this? Enceladus. Enceladus. I think that's how you pronounce it. Enceladus. Enceladus is essentially just ice as well, just kind of like Europa. It's full of ice, and underneath it there's liquid water. And there's pretty much confirmed liquid water because it actually comes spurting out the planet. Enceladus has these gigantic geysers that shoot out water at 800 miles per hour into space. And some of that actually forms a ring around the planet that I don't, you couldn't see from here, I don't think. Or maybe you can. Is that the ring that they're trying to show? But I was saying that Saturn wasn't the only thing that has a ring, and Enceladus also has a ring around it because of those geysers. So the geysers come out of the ground at 800 miles per hour, and some of it forms a ring around the planet, and other of it actually comes back and lands on the planet as snow, or falling ice, I guess. Very fine falling ice. So that's pretty much what makes Enceladus really cool. So far the two moons of Saturn that we've looked at are freaking awesome. We have one that shoots geysers out, pretty much proving that it has liquid water underneath, and then we have one that can pretty much possibly support some sort of life just because of its atmosphere. Let's move on to Mimas. Is it Mimas? Mimas. It's Mimas, not Mimas. So Mimas over here is Saturn's closest moon. It's pretty small and it's pretty much frozen solid, which is interesting. It actually presents a paradox that I read about when researching into all of this. So Mimas is a lot closer to Saturn than Enceladus is over there. Therefore, Mimas actually has a crazier orbit than Enceladus does. It's more elongated. And because of that, Mimas should have stronger tidal forces acting upon it. And tidal forces are essentially when, you know, this part of the moon is actually closer to Saturn than this part is over here. So this part gets pulled harder than this part does. And it creates like internal friction that creates heat. That's why things like Enceladus over there well, it's one of the proposed ideas for why it has water underneath. It's warm enough to liquidate that water. Instead of frozen. However, there is evidence to prove that Mimas over here is frozen solid with no liquid water underneath it. So it presents a paradox. If there should be more friction happening here, therefore more heat, how come everything is frozen solid over here when everything over there is liquid underneath? So because of this paradox, you have something called the Mimas test. And the Mimas test is if you try to explain why there's water on Enceladus, and we know that there's water under Enceladus because, again, it comes shooting out of the planet very obviously. If you try to explain why there's water there, you also have to somehow explain why there's not water here. So, it's an interesting thing that maybe if you want more information, you could look up. But yeah, cool mysteries. Cool mysteries with the moons of Saturn. We'll zoom out again like we did before so we can kind of see the distances. Well, I want to see the other one. There we go. Look at that. You can't even see it from up here, but you can see their dots or their markers. That's Titan all the way out there. Okay, this is Saturn and all of the stuff on Saturn. Now I do, before we move on to Uranus, which is actually how it's pronounced, guys. I looked it up. Before we move on to Uranus, I do want to emphasize that if you're really interested in seeing some really cool pictures, look up the Cassini probe that flew around this thing. And in fact, actually, here's another interesting thing on a little segue. The Cassini probe, it flew around this 294 times, and when it was retired, they pretty much drove it into Saturn to destroy it. And the reason they did that is because it's very unlikely that Saturn has life, but it could be likely that Enceladus and Titan over there do have some sort of life. And they didn't want to risk the idea that the Cassini probe would crash into one of those planets and introduce like microbes to the surface of those. At least that's what I read. I think it's a really cool, it's a really considerate thing to do as far as scientific discoveries go. Could you imagine that's like the equivalent of planting, like a cop planting drugs on someone? Could you imagine a scientist going to a planet and then like depositing some bacteria and then coming back and saying, oh, there's bacteria, we've discovered alien life. Nah, you planted that. The planet's like, no, I ain't got that stuff, you planted that on me. You planted those bacteria on the surface. Okay, let's move on to Uranus, which is going to be our 7th planet in the solar system. We're teleporting again. Oh, you want me to tell you why we're teleporting? Like I did for the other ones? Let me turn these off. How long of a video is this going to be if I'm explaining something for every single planetary body? Oh, I should also note as well, and I don't know that I've mentioned this. Well, I did. I said that Jupiter has like 79 moons. Saturn has like 50, I think, 52 or something. But we're only displaying a couple of them, some of the more interesting, more notable ones. Okay, so Uranus. Uranus is 4.82 light seconds away, which is about pretty much everything we've done so far. Double that, and you'll get to Uranus. That's how far that is in our model. In our model. Remember, everything is 1,000 times smaller than it is in real life. I can't even, man. Space is so big you can't even comprehend it. This is one solar system. This is one solar system in one galaxy, in one freaking whatever galaxies are clustered into. In whatever that's clustered, it's too big. It's too big, man. Space is OP. That's why we make nice little models. Uranus. Guys, I know you guys are gonna joke in the comments. That's why I'm saying Uranus. It's not pronounced Uranus, even though it's spelled that way. It's pronounced Uranus. I don't, whoever came up with the name was trolling or something. Okay. Uranus is an ice giant. But before doing any of this, I thought Uranus was like super small. In fact, Uranus is super large. It's like, I think it's 10 times the size. No, 4. Google. Uranus is like 4 times the size of Earth. So you could fit like 4 Earths in the middle of Uranus if you like put them next to each other. So it's pretty large, and I didn't know that. Uranus has rings, guys. Saturn's not the only planet that has rings. Uranus does have rings, but very, very thin ones. You can't see them in here because it's space engineers. So yeah, that's pretty much all there is to Uranus. I'm sure that's not all there is, but that's all I could really find out that was interesting. And that's unfortunate. But the real reason for that is because with every other planet, like with Saturn and with Jupiter and with Mars, we've had probes go there, and we've like looked at them and stuff. We found out what's good, you know, what's there. All that cool stuff about the moons of Saturn and Jupiter that I talked about, it's because we sent probes there and we learned about it. Cassini, freaking all that stuff. However, Uranus here is very lonely. It's only had one probe ever go by it, and that was Voyager 2. And Voyager 2 didn't even come by to visit Uranus. It passed by on its way out of the solar system. So the poor planet just hasn't been studied. It's been studied certainly from Earth, but it hasn't had something go in close and actually look at it like some of the other planets have. But anyways, let's take a look at some of the moons. I've highlighted 3 moons. We've got Miranda. Whoops, go too fast. Again, that gives you an idea of the speed we were traveling at the start, is how fast we go by these moons. But yeah, let's take a look at Miranda. Miranda is a moon. It's ice and silicate. It's pretty much what it's made of. Yeah. It's pretty much described as the weird looking moon in the solar system, and you can't really tell. Well, it looks weird from here, but you can't really tell from the model here. But Miranda is freaking. It's weird. It's got like these weird shapes on it, not like alien shapes, but like the geological features of it are interesting. It's got like wavy lines in some places, and then it's got like some super sharp cliffs in other places. In fact, there's one place in Miranda, you know, Miranda has canyons, and some of the canyons of Miranda are like 12 times the size of the Grand Canyon on Earth. So it's just a weird looking planet, a weird looking rock of ice and silicate. Let's move on to Ariel. Again, I don't have that much to talk about with these moons. Not nearly as much as before. Ariel's pretty much the same. It's not as weird looking. It's smoother. But it's just like another big space rock. And in fact, I used a moon model for these two, Ariel and Titania, because I didn't have any actual model for them. But yeah. So Ariel's just another big rock of ice and silicate. And guess what Titania is? Titania is ice and silicate. They're all boring so far until we learn more about them, I should say. Until we send a probe to Uranus and actually discover it and actually take a look deeper into like what makes it, then we're not gonna have as many cool facts about these ones, unfortunately. So without further ado, let's take a step towards Neptune. So Neptune is a little bit farther than Uranus was from Saturn at 5.42 light seconds, which means in the game, in a model, if we were to light a match here and there was a giant telescope on Neptune, it would take 5.42 seconds for the light to reach that. In the model, it would take 1,000 times that in real life. It's insane, man. It's crazy. It's crazy how big space is. Let's go to Neptune. Let's fly. Well, no, we're not flying. Are you kidding me? Okay, look at this. This is what would happen if I'm flying. I'm going full speed right now. Do you see that number changing that much? Does it look like it's changing? I'm still going. Does it look like it's changing that much? Imagine sitting through here listening to me talk. It's too much. What we do instead is we go to Alt F10, Entity List, Planets, and we teleport, my dudes. We teleport! Because ain't nobody got time for that. Ain't nobody got time for that. Ain't nobody got time for that. Oop. A little fast there. All right, Neptune, kind of like Uranus, is another ice giant. Neptune has an atmosphere of hydrogen, helium, and methane. If you guys don't know what methane is, by the way, pretty sure it's what cows fart. Don't quote me on that. Methane. It's also the reason why when you go next to a trash dump, you see those pipes like that kind of stick out of the ground. It's because if methane builds up, it becomes explosive, and you don't want it to build up and explode your trash. Pretty much. Yeah, so methane is in this place. So kind of just like Uranus, Neptune wasn't specifically visited for the case of studying it, but Voyager 2 flew past it on its way out of the solar system as well. By the way, the Voyagers are really cool. You can go and look up where they are. They're just kind of flying out in space as fast as they can go. But Neptune, an interesting thing about Neptune is that it was the first planet to actually be mathematically predicted before being discovered. So they didn't see Neptune, but they were like, you know, math says there should be a planet here. And there was. Neptune has a moon. It's called Triton. Neptune has more moons than Triton. I think Neptune has like 12 moons. But Triton, not Triton. I'm looking at my... I have a pronunciation cheat sheet because some of these are hard to pronounce. Like especially, what was the one I had trouble with? Enceladus. That was the hardest one to pronounce. But Triton here is the only moon in the solar system to orbit retrograde of the planet's rotation, which means, in other words, that the Earth rotates away, the moon orbits that way that the Earth rotates. But with Neptune here, Triton orbits the opposite way that Neptune rotates, which is interesting. That's kind of rare. And one idea for why that might be is because maybe Neptune captured it. But yeah, Triton's cool. Triton also has volcanic activity, which is always a fun thing for planets to have. Okay, Neptune is done. Let's take a look at our final set of not planets, dwarf planets, I guess. Oh, let's do the same thing. We'll do K. We'll turn off these ones, and we'll turn on the other ones. So just so we can see how far it is. Pluto. Pluto's like everyone's favorite planet, man. Everyone loves it. Oh, you guys are gonna laugh at me when I pronounce the name of its moon as well. Pluto's not as far away as Neptune was from Uranus, but it's still like light seconds away. So we're teleporting. All right, here's Pluto, characterized by that red bit of surface. There are some really interesting facts about Pluto, by the way. So the atmosphere of Pluto, yeah, Pluto actually does have an atmosphere, is made up of nitrogen, methane, and carbon monoxide. You guys know carbon monoxide, the thing in cars that will kill you if you breathe in too much of it. But yeah, Pluto does have an atmosphere of very thinness. Other things about Pluto that are very interesting, you can Google this stuff if you want to learn more about them, but Pluto has snow, but it's red. It's got red snow. The snow is methane. It snows methane on Pluto, and the snow is red, pretty much. Pluto's got cool mountains. Pluto has water ice in some areas, which is crazy. And Pluto also has a blue sky. The sky if you were standing on Pluto, the sky would be blue. How crazy is that? Something you'd never think of, probably. And then, of course, other than Pluto, we've got over here, really close actually, as moons go to dwarf planets, I guess, is, you guys are gonna laugh. It's pronounced Charon. I know, it looks like Charon, and that's how I pronounced it before, but it's actually pronounced Charon. If you Google it, it's pronounced Charon. So Charon here wants to see Pluto's manager. No, not really. Charon and Pluto have a very interesting relationship in that they are tidally locked to each other. So even, like, Charon is kind of orbiting around Pluto, but Pluto is rotating at the same speed that Charon is orbiting, which is really cool, because that means that even though it's like another body, you know how the moon can like rise and set as the day goes, depending on where you are on the planet. Charon doesn't do that. If you're standing here and you see Charon right there, Charon will always be there, because the speed at which it rotates is the same speed at which that orbits. It's really cool. Charon will never rise or set. Charon will always be there, watching, waiting. But yeah, that's the cool stuff, isn't it? Charon and Pluto, the two soulmates, I would say, because I think they're the only duo planet thing in the solar system. They kind of go together, like blah 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 dinkity dink dink. Does anyone didn't get that reference? I probably butchered it. I don't know the words, and it's kind of probably before some of your time. Grace is the word that you heard, It's got something and something. Bam, bam, bam. It's the time and the place and the motion. Da, 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 da. If you guys haven't seen Grease, you have to watch Grease. Okay, there we go. That's all the planets and all the moons in our thing, in our 2-scale solar system, our 1,000 scaled solar system, which is amazing. That's incredible. I know I kind of moved away from planet sizes towards the end and moved towards the facts a little bit, but I felt like the sizes don't really matter that much. Pretty much Neptune is the same size as Uranus, which is like 4 times the size of Earth. Mars is like half the size of Earth. Venus is the same size as Earth. Mercury's like a little bit smaller than Mars. Saturn and Jupiter are the real big boys at 69,000 kilometers and 58,000 kilometers in diameter. Or in radius, rather, not diameter. And then the other major takeaway is that some moons, like Titan and Ganymede, are actually larger even than the planet Mercury, which is pretty crazy. But yeah, there we go. Do you now get the sense that space is gigantic and huge, and it would take you forever to go from point A to point B? Well, let me drop this bomb on you then. That whole distance we traveled from the sun to Pluto, the 19 light seconds that we traveled in our model, is only about 1/26th of the way to the real life Earth. So if you wanted, if this were full 1-to-1 scale and the sun were there, we would have to travel this 26 times that way behind us to get to Earth. Let that sink in for a second. That's how large. And Earth wasn't even, we flew to Earth. Do you remember the days when we were flying to planets before we were teleported? We flew to Earth without a problem. Now just imagine doing this 26 times. And imagine how close Earth actually is to the sun compared to something like Jupiter or Neptune. It's insane, guys. It's insane. It's absolutely insane. And if this isn't enough for you guys, by the way, there is actually theorized to be a planet X, if you will, a 9th planet, or if we're counting Pluto, a 10th celestial planetary body called Planet X. That is, well, Pluto is almost 6 billion kilometers away from the sun in real life, not in the model. In the model, it's only about 6 million kilometers away. But if Pluto in real life is 6 billion kilometers away from the sun, this Planet X that's been prophesized to be out there is almost 90 billion kilometers away from the sun. That's like 13 times farther than Pluto. So do this distance 13 times and you'll get to where our model Planet X would be. But the interesting thing about Planet X, and I don't know how true this is, it's kind of something I read recently, is that some scientists believe that Planet X might be a black hole. I don't know how much truth there is to that. It's just something I read, and you should probably do some research if you're interested in that. But could you imagine that? A little black hole orbiting our solar system, orbiting our little sun. That's pretty amazing. All right, it's probably about time to go check in on that car to see if I owe that guy $100 or not. Let's go check in on him. Let's fly all the way back there. No, I'm just kidding. We're not going to fly. It's going to take way too long. It's too far. Oh, hi, person. Hi, Elon Musk. Oh my God, look at it. That's Mercury. That's the sun. So in the time I've been recording, which is about 50 minutes, I don't know how long the video will be, probably a lot less. But in the time I've been recording, this thing has traveled only about like 6,000 kilometers at the speed it's going. How interesting is that? And it's actually weird. I did see it. I wonder if it got caught in the gravity of something, because I did see it gaining speed and losing speed earlier. It was losing like oh, it's still losing a little bit of speed. So I don't know where that speed's being lost. Probably something to do with those wheels. But yeah, it's only traveled 6,000 kilometers at that speed, that insane speed. It's not even out of the normal solar system yet. Oh my God. Okay, I think that's a really good place to end this episode. And I think that proves the point perfectly of how big space is, that if he's going this fast, he's only this far. He's not even close to Mercury. How the heck is he going to get to Pluto, right? It proves my point perfectly, so it's a great place to end this. If you guys have any questions or comments or concerns, please post those down in the comments. There were a lot of facts said in this video, and all these facts were just researched by me and written down somewhere. So if I got anything wrong, which is entirely possible I did, please post those down in the comments and I'll address them in like an updated comment with corrections or something. If you guys have any interesting facts of your own to add, please also put those in the comments, because there's a lot of interesting things about space, and I'm sure a lot of you know a lot of cool stuff that I don't know quite yet. But yeah, if you like the video, please hit the like button, put your comments, suggestions, and anything down in the comments section below, and I will see you guys in the next episode of Space Busters.
I normally play in creative because I like being creative. What's down here? Upgrade more of those. Alright, she'll be back. Let me just.